49. This sheet, normally I take a whole period to do this. We get out rulers and we do some work with it. Not going to do that because it's summer school, we don't have time. I'm just going to tell you what you need to take away from this sheet. Okay? Some of you will not have done what we're about to do. Some of you know what we're about to do. So if you already know, it's a bit of review, sorry, but it's actually really important to trig because people often screw it up. All right? So the first thing we're going to do, we're going to talk about is how we label triangles. Remember, write down as much of this as you feel you need. Some of you won't need to write down any of it. Some of you will need to write down all of it. Okay? Angles, which are also called a vertex, are labeled in caps. So A, B, C. Capital letters on the corners of all shapes, not just triangles. We always use capital letters for the corners. Okay? Sides are labeled lower case. And there we go. And there's a trick to this. Sides are named by the angle across from them. So what would this side of this triangle be? Little c, because it's across from big C. What would this side be? Lil b, because it's across from big B. What would this side be? Little a, because it's across from big A. Now, please highlight, underline, put a circle around it, put a star by it, make a Mrs. Bad Crumble cloud around it. I don't care what you do. Call your attention to the word across, because in trigonometry, the word across has a different definition. That definition is opposite. Opposite means across the shape. So from wherever you start, whatever corner you start at, when you go across the shape, you have gone opposite. Sooner or later, that will wake up. There we go. Okay? Everybody got it? So that means in this big triangle, what is this side? Little d, because he is what? He is opposite from where? Big D. What is this guy? Little f. Why? Because he's opposite from big F, for F's sake. What is this guy? Little e. Why? Because he's opposite big E. Everybody got it? Opposite means across. Okay? It's not a complicated concept, and yet, when we get into trig, people are, I don't know how to do it. But you all know opposite means across, yes? Okay. All right, the next thing we are going to talk about is, again, normally I'd do a whole big long thing with this, but it's summer school, we don't have time. Which I'm going to color that side yellow, and then I'm going to color this side green, blue, and pink. Which side on the bottom triangle is in the same position as the top triangle? The green side. Everybody understands that, yes? Okay. That yellow side, little b, if I make a fraction with little e, that fraction is going to be the same as if I did A and F and C and D. All of you should already know that, correct? Please notice that they must be in the same order. The numerators all came from the small triangle, and the denominators all came from the big triangle. There's no rule about which triangle you put first, but you have to keep that same order. Does everybody understand what I am saying? All right. How does this help us in real life? This is how we build stuff. Okay? They don't build a giant building in Vancouver, take it apart, bring it out here, and build it again. They have a plan. And that plan is also not life-sized. It's little. And then they use this relationship to make it big. How it works is this. If I tell you that B is 7, and I tell you that E is 12, and I tell you that C is 14, you should now be able to tell me what D is. How do we do that? You use this relationship. B, which is 7, compares to E, which is 12, because they are in the same spot on the triangle. Does everybody understand that? Even if I turn this triangle over here, around or upside down or whatever, that's the same side. It's the second longest side. So those two compare. And that fraction would have to equal to the comparison of what? C to D. Which is in the numerator spot? C or D? 14. C. Because I have chosen to put the smaller triangle in the numerator spot. And then down here would be D. And then we would cross multiply to solve. Everybody knows that already. You should have learned that in either grade 7, 8, or 9. Everybody knows that, right? And everybody understands why it works, right? Okay. That is the basis for trigonometry. So those of you that have never seen trigonometry, if you understand Pythagoras and you understand this relationship, then you will have no problem with trigonometry. All right? Everybody cool? So what would the answer for D be? What would you do to solve that? Cross multiply. 12 times 14 divided by 7. Right? 12 times 14, and then divide all that by 7. And you would get whatever it is. 196 divided by 7, which is it is 24. Okay? Yeah? All right. So everyone's good with similar figures, yeah? Everyone's good with Everyone's good with Pythagoras, right? Did this thing not record? Oh, no, it's recorded. Okay. All right. So we're all good. So if you would be so kind as to flip to page 53. Okay, for those of you who have done trig before, this first couple of moments of trig are going to be a little bit boring. For those of you that have not done trig before, you need to pay real close attention. Okay? We're not going to use rulers. We're just going to sketch it freehand. But we are going to connect A all the way out to D, A all the way out to H. Actually, we're not going to do that. I'm going to change my mind. We're just going to go A to B. So everybody draw a line from A to B and A to F and then B to F. Okay, what angle did I make right here at F? It's 90 degrees, right? Which means I can do Pythagoras here, can't I? Okay. How long is A to F? 1, 2, 3, 4. Agreed? 4. How long is B to F? 3. So since this is 90 degrees, we know we can do Pythagoras on A to B, and we know the answer is going to be 5. Is everybody cool with that? Okay. So now I'm asking you here to tell me the ratio. BF. How long is it from B to F? 3. A to F is 4, correct? That gives us a ratio. What's the other way in math we can write a ratio? Fraction. So this is also 3 over 4. Cool? Everybody with me? All right, if you've done trig, you know where I'm going with this. If you haven't, just pay attention. Now, I'm going to draw a blue line. Make that one. That one's going to be yellow. Got my yellow triangle. Now, I'm going to draw from A all the way out to C, and all the way out to G, and up to C, making another 90 degrees. How far is it from A to G? 12? 12. And how far is it up and down? How far is C to G? 1, 2, 3, 4, 5, 6, 7, 8. Oh, crap. Stupid. Damn it. Make that dot 1 higher. I drew that badly when I made this book. I got to make a note to myself to change that. Make it 1 higher. That's 9. Now, what is the ratio of CG to AG? Nine to 12, because CG's got to go first. Now, when I write that as a fraction, 9 over 12, would your grade 3 teacher be happy if you left it that way? Sydney? Because I wrote CG first. Would your grade 3 teacher be happy with 9 over 12? 3/4, right? She or he would have said reduce it, which isn't really what you're doing, but that's what you were told. So what does that tell you about these two ratios? They're the same. So BF over AF equals CG over AG, correct? Okay, now I have two totally different triangles there, don't I? I got the yellow triangle, and I got me the blue triangle, which goes all the way into here, yeah? Right? What is the only thing that is shared between both triangles? Just this angle A, yes? No matter how long I made these legs, that right there stayed the same, didn't it? What's going to happen on the third one? Those of you who've done trig already know the answer. When I go all the way out to H, what am I going to get? $12, $13, $14, $15, $16, $17, $18, $19, $20. So A to H is going to be 20. So I'm going to draw out to there. So what does this have to be now? I screwed up. You got to draw it. You got to go up a line. And you know it has to be 15 because that fraction has to be the same. Right? Because if it happens once in math, how many times does it happen? Every time. That's why math is awesome. There's no surprises. Because when I make this big triangle, which is going to be pink, Does that angle A still get shared with it? Yes. What if I drew this line right here, all the way over to Souk Mean, and I drew this line all the way over to that filing cabinet? I would get the same fraction, right? That's what trig is. No matter what, no matter how big you make the lines, you always get the same ratio. So the general statement is simply this. Regardless of length, the ratio stays the same. Everybody understand that? So no matter how big I make those lines, I'm going to get the same ratio. Now, we all hate fractions. What do we like better than fractions? Decimals. How do I turn that fraction to a decimal? Divide, right? So, if the ratio stays the same, what does that mean about the decimal? The decimal stays the same. Is everybody cool to there? Even the people that have never seen trig, you're all okay with that, yes? Because it makes sense, right? We've drawn it, we've proven it, right? Okay. This is called the tangent ratio. Tangent. And it holds true for all right angle triangles. And what is that ratio? I'm going to erase some of my ink here. And I'm going to only keep the biggest triangle. All right, so this is a right angle triangle, yes? Now, what was the comparison we made? We took this side and we compared it to the bottom, yes? And this was the angle that we were starting from. When I start from this angle, what are the two things that I compared? I compared that side and I compared that side, yes? What is the word in trigonometry for going across a shape? Opposite. So I compared my opposite side to, now people who have done trig before already know the name of this side. It is the opposite side compared to the, now, if you haven't done trig, you don't know the name of this. But you know the name of this long guy. What do you call the long guy? Hypotenuse. So I am comparing the opposite to the side that's not the hypotenuse. And there's a name for that in trig. It's the adjacent. So I'm going to highlight that because that's another new word if you haven't done trig. Adjacent is the side that's not across, and it's also not the hypotenuse. And that's a perfect time to stop, because we're about to start doing something that is a super pain in the butt. When the bell rings. All right. The bell hasn't actually rang yet. But I will. There it is. Okay, so this is where we left off. I'm going to finish. Then you're going to do some work. While you're working, I'm going to finish marking. Then we're going to go over that. That should take us to pretty close to the end of this block. You'll come back. We'll do one more set of notes. I'll give you one more thing to work on, and that'll be the end of the day, I believe. Yeah, sure. You betcha. All right, so now, as I said, that was the perfect time for the bell to ring because we are now in a very painful spot for math teachers. All right? I need everybody to have their calculators out right now. Those of you who have already done trig know what we're about to do. Those of you that don't, you're going to see this for the first time. If you still have not gotten a calculator, you are still trying to use your phone, this is going to be a very difficult unit for you. If you have not bought a calculator yet, make sure you buy the right kind of calculator if you're going to go out and buy one. If you would be so kind, Andrea, as to hand me your calculator for a moment, that would make my life very easy. If you do not have a calculator yet, and you are thinking about going and buying one, make sure you get one that does this. When you push the button tan, it writes the word tan on the screen. If you have not bought a calculator yet, you are going out to do so, make sure it will do that. It is easier to work with. Okay? Okay. If you are using your phone, especially the iPhone calculator, you are going to have a giant pain in the butt for this unit. And it makes my life a giant pain in the butt. So you may want to think about that. All right. Now, next thing. Everybody should be looking at their calculator screen now. Somewhere on that screen, you should be seeing a small capital D, or the word D-E-G. Everybody look at your screen and make sure you can see one of those two things. If you see R, rad, G, or grad, if you see any of those four, please put your hand up so we can fix your calculator. Yes. No, on the screen, not a button. Do not look at the buttons. Look at the actual screen. What do you have, Fawaz? Grad? Okay, so you need to find the button that says DRG and push it until it says DEG. Shireen, what do you have? RAD? Same. You have R? Same thing. Find the button that says DRG and push it until it says D. I need everybody's calculator showing them the word DEG or the letter D. If you have a very fancy calculator like Haley, yours is a real pain in the butt. But I will show you because it's almost the same as mine. Do you have it? Okay. Is everybody on D? What we're about to do will let me know if you are on D or not. Everybody with your calculator. If your calculator does what I showed you on the screen like Andrea's does, that's what I call a forward calculator. If you push tan and it writes the word tan, then I want you to go ahead and push tan 35 equals. If your calculator doesn't write the word tan, you have what I call a backwards calculator. And in that case, you simply reverse the order. You do 35 tan. And you probably won't need to hit equals. Everybody do one of those two things and tell me what your calculator shows to the third decimal place. Yes, it should say 0.700. No. It should say 0.700. Well, it'll be more. It'll be longer. But the first three decimals should be 0.700. Does everybody have their calculator in the right mode now? Okay. Why? Does your calculator have a D on the screen?
No, it's a stat rather than.
So I did that whole big thing over here with DRGs, said like 5 times, does it show D? And you were just like, okay.
No, I just.
Push the button that says DRG until your calculator says D.
There's no D. It's just like. There's only D, G.
DEG is the other thing it's allowed to say.
Oh, I thought it was had to be only D.
No, that's why I did the whole thing with D, R, and I wrote DEG, RAD, and GRAD, that whole thing there.
Oh.
Right. There you go. Everybody was able to do it, yes? Okay. Now, tell me what tan 15 is. 0.267. Okay. 0.26. It's actually 0.268 because it's 2679. And finally, what is the tan of 45? Is 1. Now, these are decimals, yes? But a decimal is just a fraction, isn't it? This fraction right here is the same as 0.7, correct? Which is 7 over 10, correct? Which means if I drew this triangle with a 90 degree there, this is the angle that I am looking at. Where does the 7 go? On the bottom, on the right, or on the hypotenuse? On the right. That would be 7. That would be 10. Does everybody get it? Okay. Could this be 14 and this be 20? Yes. Could this be 21 and 30? Could it be 70 and 100? Yes. Because 70 and 100 would be 7 over 10 still, wouldn't it? Everybody good? Okay. So now, what's this one? That is 268 over 1,000, isn't it? So if I drew that triangle, where would the 268 be? On the right. And where would the 1,000 be? On the bottom. Is everybody cool? Okay. Now, you should notice that that gave me a decimal, that gave me a decimal, but that gave me 1. Why? So if I drew that triangle, 1 is 1 over 1, isn't it? So where's the 1 go? There. And the other one goes where? There, right? If these two angle sides are the same, what does that tell us about these two angles? They have to be the same, don't they? And if this is 90 degrees, because it is, how many degrees are in a triangle? 180. If I've used 90 of it here, what's left for up here? 90 degrees. And since they're the same, it must be 90 divided by 2. Everybody with me? That's why 45 is 1. Is everybody cool? Okay, now I'm going to ask you a question. What do you think will happen since I went decimal, decimal, whole number? What if you were to put in the tan of 70, which is bigger than, don't do it, bigger than 45? Will it be a decimal or will it be a number bigger than 1? Try it. Right, because you already tried it. You weren't supposed to try it. You're supposed to guess. That's okay. All right, is everybody cool with the tangent thing? Okay. Your calculator will give you the decimal that goes with the fraction. Everybody cool? All right, now you guys are smart kids. does that fraction, if I tell you, if I were to erase that, does that mean anything to you if you were drawing the triangle? No, the 268 means nothing, does it? I don't know what that is. Your calculator does, though. It can work both ways. And here's how that works. So I push tan and then a number, and that gets me the decimal. That decimal is a decimal representation of the ratio that we just did, right? 7/10. Everyone's cool with that, right? That doesn't tell me the angle. Your calculator can tell me the angle when we work this way. So when I look at this question, what do I have? Do I have the angle or do I have the ratio? I have the ratio, don't I? I have the ratio of 75/100, correct? Which is 3/4, isn't it? We've already dealt with the tan ratio of 3/4, haven't we? That's the one we were drawing at the beginning. So we know that this angle had a ratio of 3:4, right? So if I went all the way out here 100 and I went up 75, those two lines would still meet up, right? But that doesn't tell us how big this angle is, does it? Your calculator knows. And you find it by doing the exact same buttons with one extra button. Those of you who have done trig already know how to do this. Since I know the ratio, I need to use this function. And if you look on your calculator, you will see that is the second function right above tan. You follow the same sequence of buttons, except you have to push second or shift, whichever button you have. So for this, I got to go shift tan 0.75, and I will get what? 36.8698? 86. Okay. So 36.9 degrees. Everybody cool with that? That means that this angle is 37 degrees. Everybody cool? No matter how big we make the triangle, that will always be 37 degrees. Everybody good? That's why trig is awesome. I can draw a little triangle this big on a piece of paper, and then I can build a stadium full size, because the angles will all be the same. Now, I don't want to talk about B for a moment. Okay? I don't want to talk about B right now. I want to go over to C. Everybody tell me the angle for C. So tan -1, which is shift tan, equals 68 degrees. We don't usually bother with decimals with our angles, because believe it or not, angles are measured like time. They're not measured with decimals. Angles are broken down into minutes and seconds. Pardon me? You can put the decimal there, I don't care. Everybody cool with those ones? All right, so what do we know? Tan will find the decimal. Shift, no, wait, I don't want to write it that way. Shift tan will find the angle. I'm going to highlight that to remind you of it. Now again, a bunch of you already done trig, you already know this, a bunch of you haven't, so that's news to you. Now, what's weird about B? It's got a negative. What happens on your calculator when you push, when you try to find that angle? What do you get? Pardon? You get a syntax error. Okay. So Amrit got negative 51 degrees, right? Okay. And Andrea got syntax error, right? Yeah, I was just going to say, you could probably do brackets. Your calculator will show you this. Where do you think, because this isn't part of, regular grade 10, I'm just showing you how it works. Where do you think negative 51 degrees lives? Because here's how we normally do an angle, right? Agreed? That's an angle, right? So, and that would be some amount, right? Okay. Well, what if I started on this side and drew that? Then it would be down there, wouldn't it? But they're the same angle, aren't they? Okay. I'm just giving you guys a bit of a heads up for next year for a bunch of you. In trig in grade 10, all our angles are between 0 and 90, aren't they? It's a 90-degree triangle, right? How many degrees are there? 360. Because it goes all the way around a circle. So next year, your trig will go from 0 to 360. Negatives are just the opposite direction. So normally we would count this way. This way. But a negative is the opposite direction, so I would count this way. So I would go down 51 degrees. Now, if I go all the way around a circle, what do I get to? How many degrees are in that whole circle? 360. But I didn't go 360. I went 51 less than that. So that is 309 degrees. Everybody cool? Now, if you do tan 309 with your calculator, guess what you're going to get? Yep, just regular tan of 309. Negative 1.23. Everybody with me? I'm never going to test you on that in grade 10. I'm just letting you see that trig goes beyond 90 degrees. Okay, it doesn't end there. Because you can see in the real world there are more degrees than 90, right? Any of you that go to Abbey or have been in Abbey know we've got that big circle thing out front. That's 360 degrees. They had to build it somehow. Everybody with me? Okay. So let's actually try to apply this. Given the triangle, find the tangent ratio. Oh, I'm sorry, we've got to fill in this box, but you already know it. The tangent ratio compares the opposite measurement to the adjacent measurement. And what's the one side that we're never allowed to use for tan? No hypotenuse for tangent. Okay? So, now here is where trig gets difficult. It's not really difficult, but people have trouble with it. I don't know why they do. What does this question say? Which angle does that question say I am working with? A. Where is angle A? It's right there, yes? So I'm going to draw me at angle A. Is everybody cool with that? Because the question tells me I'm at angle A. Everybody good? I want the tangent of angle A. Tangent is always opposite over adjacent, yes? So what is opposite of me right now? 12. So tangent of A is always opposite over adjacent. Opposite 12, adjacent is what? What is adjacent to me? That's the other side that isn't the hypotenuse. 5. Everybody cool? All right. Now, over here, when I am on this question, where am I now? angle B. So I slide down the triangle, and here I am at B. Now, what is opposite to me? The tan of B is still opposite over adjacent, but now my opposite is what? 5, and my adjacent is what? 12. That is where kids have trouble with trig. If you haven't done trig before, and if you have done trig before, that's probably where you started having your issues. How you do trig depends on what angle you are using in the triangle. All right? It can change. You do the same method, but your answers will be different. Is everybody cool with this? Okay. So now, what do we have? We have ratios, don't we? Our calculator knows how to take those ratios and give us the angle, doesn't it? Except when we found the angle with our calculator, we had decimals, yes? Do we have decimals right now? No. So I need decimals, don't I? Now you can do this the long way. You can find the decimal, write it down, transfer it into your calculator, or you can do it all in one step. Here's how to do it all in one step. If you have a forward calculator, since we're looking for an angle, is it tan or shift tan? Shift tan. If you have a forward calculator, you are going to punch shift, tan, bracket, 5 divided by 12. Will that find me angle A or angle B? Which one? B. And then equals. And what is it? 22.6? 62, so let's call it 23. Everybody cool? So what then is angle A? Do you have to do 12 divided by 5? Or can you do 90 minus 23? You're allowed to do both, right? The other angle is 67 degrees. Is everybody cool with that? Which part, Sydney? Yours is the backwards calculator. Oh, that's why I haven't done backwards yet. On a backwards calculator, which I'm going to do in red, well, it should have been red. It didn't come up red. Red. How many people have a backwards calculator, by the way? Okay, a few of you. All right. So you just reverse it. So you are going to go bracket 5 divided by 12, close brackets, shift, tan. And you should get 23. All backwards people are good? Okay, so now I kind of cheated and we did this step, what you actually punch in. This is key though. I want you, for your calculator, to write down which of them you do. Because I don't want to have to constantly be saying forwards and backwards calculator. I just want to say you shift hand to find it. Everybody with me? So you write down what you did. If you don't need to write it down, you know what you're doing, you're awesome at trig, don't. I don't care. But make sure you know how your machine works. Everybody good? I'll take a second while you get that written down. All right, so now we're going to do a little bit of work here. Before we carry on, I need you guys to be aware of something we use in trig. We use this symbol. It's a circle with a line through it. Some of you will have seen it, some of you won't. It's a Greek letter. It means theta. And we use theta to substitute in for some angle. Okay? If there's an angle that you're dealing with and you don't know exactly what it is, you call it theta. Everybody cool? So every triangle, whenever we're doing trig, has some angles in it, right? We are going to work with one of those angles. That angle is theta. Everyone cool? All right. So in this triangle right here, I need to find one of the angles. Which angle do I need? I need that one right there, yes? Because that's where the x is. So what is my theta? Do I know it? So I write x. If you write out trig, you cannot do it wrong. It's impossible. Now that I know I am working with x, I'm going to look at the triangle and see, oh, there's an opposite. So my opposite equals what? 23. And then what's this side? 15, but what do we call that side? Adjacent. Now what do we know? We know that tan theta is always opposite over adjacent, don't we? Right? Tan of every angle is opposite over adjacent. Fill it in. I don't know theta. Tan x equals opposite 23 over 15. Do I have the decimal or do I have the angle? I have the decimal. So is it shift tan or regular tan? Shift tan. And you punch it in. So everybody that hasn't done trig, you've done trig, this is boring. If you haven't done trig, please make sure you're practicing. How do I punch that into my machine? You just wrote it down right here. So for my forward calculator, it's shift tan bracket 23 divided by 15 close brackets equals. So we're going to round that off because it's a degree to 57 degrees. Is everybody good? All right. Let's look at the next question. Again, if you write it out, you cannot do it wrong. Do you have a theta? Do you have an angle in that question? What is it? 15. Excellent. Once you have decided you're using 15, that's where you are starting from. So now you look from there. So there's an opposite. What is it? X. And there's this side. What is that? Is that adjacent or a hypotenuse? That's adjacent. What do we know always when we have opposites and adjacents and a theta? We know that tan theta equals O over A. Fill it in. Tan of what? What's theta? 15 equals what? O over A. What's O? X. What's A? 37. Now, stop for a second there. Tan 15, we know is just a number, don't we? But do we know it off by heart? What knows the number for tan 15? Your calculator. So this, and I have a variable here, don't I? What's my job every time I have a variable? Get it by itself. How do I get rid of divided by 37? Multiply. So this must be 37 times tan 15 equals x. How do you think I punch that into my calculator? Exactly the way we've been punching everything else into our calculator. If you got a forward calculator, 37 times tan 15. If you got a backwards calculator, 37 times 15 tan. What do you got to hit at the end? Equals. So many backwards calculator people do not hit equals because as soon as you hit 15 tan, your screen changes and then everybody stops. But you haven't hit equals, have you? So what is that answer? 10. X equals 10. I just got to check that to make sure everyone's punching it in right. $9.91, yeah. So, Now, guys, there's a little bit of a rule here. Angles, we round, almost always. Sides, we go 1 decimal place. Generally. Everybody cool with that? And the reason is simply because angles, we don't divide them into points. We don't divide them into decimals. They're like time. All right, so I'm going to shut up for a second, and I want you guys to tell me what you would write over here to do this right. Amber. How do you know when to use tan or shift tan? I'm about to tell you when we write this out. It's like you read my mind. So, do I have a theta? What is it? 70. Now, once I have 70, that's where I'm starting, right? So what do I have? What's opposite to me? 14. What's adjacent to me? X. Now, Amrit, you just asked, when am I going to use tan? When am I going to use shift tan? When I have a theta, I use tan because I know the angle. When I don't have a theta, I have to do shift tan because I don't know the angle. Shift tan finds angles, tan finds sides. So I'm going to write that little memory tool right over here. Shift tan is for angles, tan is for sides. And since in this question I'm looking for a side, I must be using regular tan. And I just fill it out. You can't do it wrong if you write it out, and it only takes 1 second. Tan theta equals over A. What's theta? 70. What's O? 14 over X. Now I just do algebra, which is cross multiplying, right? The shortcut is this. When the letter's on the top, we multiplied. When the letter's on the bottom, we divide. So X equals 14 divided by tan 70. And what does that give you? 5.1, because it's a side, so we like 1 decimal place. Is everybody good? Okay. Even the people that have never done trig before? I'll go back up. Is everyone cool? Yeah? All right. Remember, this is all going to be on YouTube, so no needs to worry too much if you get a little bit behind. All right, go on to page 55. What's weird? There's 2 variables. One of those variables is the hypotenuse. So can I use tan for it? No, because tan doesn't work for the hypotenuse. What finds me a hypotenuse? Shut up! Pythagoras finds me a hypotenuse. So, again, if you write it down, you can't screw it up. Do I have a theta? What is it? 30. That means I'm over here looking happy. What do I know? I have an opposite, I have an adjacent, and I have a hypotenuse. What's my opposite? What's my adjacent? 24. Once I know that, I can find X, can't I? Amrit, am I finding a side or an angle here? Side. So is it tan or shift tan? Tan. Excellent. Tan, what's my theta? 30 equals opposite, which is what? Over what? 24. Number on the bottom, multiply or divide? Multiply. 24 tan 30 equals X. What's X? 86, 13.9, right? Now, all of you should be looking at 13.86 on your calculator right now, right? I've written 13.9. Do I have more work to do? Yeah. Am I going to need that 13.86? Probably, so don't clear it off from your calculator. We've written it down here, but our calculator is showing it all, yes? How do I find y? Well, I know that y equals the square root of what? The other two sides. So 24 squared plus, we already know what x is. What is it? 13.9, but it's already sitting on your calculator, isn't it? Right? So on your calculator, all you got to do is square what's there, add 24 squared, and then square root the answer. I'll show you what I mean. Oops. I'm in the wrong mode. There is 13.86, 13.9, right? So now, if I square it, and I add 24 squared, and I get an answer, then I square root that answer. Y is 27.7. Is everybody, and when I say everybody, I'm really stressing the people that have never seen trig before. Is everybody comfortable with tan? Okay. I don't expect you to be comfortable, but I do expect you to have a vague idea of what is going on. So now I want you to set these three up. You don't need to do it yet. Just set them up. Sydney. You can't have 24 because you know this side's 24, so the answer has to be longer than 24. Did you get the 13.9? Did you square it? Did you add 24 squared? Did you square root the whole answer? Did you square root 24 squared? You forgot to hit equals because you square rooted 24 squared. That's why you got 24. Okay? Try it again. Because that's all it is. It's just calculator work. It's not concept. Please understand the difference, everyone, between I screwed up with my calculator and I don't understand math. They're two totally different things, aren't they? You get it this time? Okay. I'll come back and talk to you in a minute. Because that's calculator issues. That isn't math issues. I'm about to shut up and let you guys do some work in a second. All right. I told you I want these three set up. So in this first one, what's my theta? And once I have the x, what's my opposite? What's my adjacent? 50. Let's go to this one. What's my theta? 60. What do I know? Opposite is x, adjacent is 7, and my hypotenuse is y, which means I have to do Pythagoras. And finally, over here, what's my theta? 80. What's my opposite? What's my adjacent? Now, those are all set up for you. You should be able to do them, yes? Go ahead and do those while I come around and check anybody who's having trouble getting the exact right answers. Thanks. 14 divided by 7 10. Yes. You just reverse. You have a backwards calculator. You just reverse when you push tan. So you write tan 70, and you push 70 tan. Three. Oh yeah, because you got the scientific thing. This is why this is the worst unit. Everybody's calculators always have to. Always. So while you guys are doing this, some people will have it done, some people won't. This one, do I know the angle? So shift tan or tan? Shift tan. Shift tan of x equals 35 over 50. Right? Punch that into your calculator. What's your answer? 35? I believe you. He says as he punches it in anyway. 35 degrees. Abso-smurfly correct. Come on, wake up. How'd you get 35? Same way we've been doing it all the way along. Shift, tan, 35 divided by 50. Close the brackets, equals 35. Okay? You need brackets. All right, what about the red one? Tan, do I have a theta? What is it? Tan 60 equals opposite, which is what? X over adjacent, which is what? 7. Number on the bottom. So what is that? Multiply or divide? Multiply. Think of algebra. To get rid of divided by 7, I'd have to multiply, right? So it's 7 tan 60 equals X. Punch that into your calculator. 7 times tan 60. So X equals 12.12. Now, how do I use that to find Y? I Pythagoras, right? I know that Y equals the square root of X squared plus 7 squared, correct? And X is sitting on my calculator right now, isn't it? So if I go squared plus 7 squared, I'm going to get an answer, right? And then what do I do with that answer in Pythagoras? Square root it. So Y is 14. Everybody cool? Okay. And then our last one. Do I have a theta? Tan 80 equals opposite 10 over X. Now, if we were doing algebra, it's a long path, isn't it? Multiply both sides by X, then divide, right? So I gave you the quick little shortcut. When the letter's on the bottom, we divide, right? So X equals 10 divided by tan 80. And that's about the hardest thing to punch into your calculator in trig at your guys' level. So that's why I wanted you to practice it early on and write down what you have to push. What's our answer? So 1.8 we'd probably write, but 1.76 is fine. I don't care. Again, decimals are the least of my concerns. 1 sec, Ekdeep. Is everybody cool with math class trig? Because this isn't real life, is it? This is all stuff written on a piece of paper, right? Okay, Ekti. Yep. 7 times tan 60 equals. Tan 60 equals. Do you have a forwards calculator or a backwards calculator? Well, okay. So that's why, again, I got you to write it down, what you have to push. And I've said it about 100 times. I'm going to say it again. Listen to me. If you have a backwards calculator, you have to reverse the number in the tan. So it's 7 times 60 tan equals. Okay, you got it? All right, Sid. There is no stupid questions. There are stupid questions when you ask the same thing 150 times. Because that means you didn't listen to the previous 149 answers. The black one? Yes. Okay. I'm skipping a bunch of steps, but really what is happening, it is this algebra. How do I get rid of x on the bottom? I multiply both sides by x, right? So now I've got x tan 80 equals 10, yeah? I want to get x by itself. X times tan 80, right? Right? How do I get rid of times tan 80? Divide. So I would divide both sides by tan 80, and I'd end up with x equals 10 divided by tan 80. I'm just skipping to that. Okay? Everybody cool now? All right, now remember, this is not real life. Okay, this is not the real world. This is a piece of paper. Everybody good? Can everybody do tan with a piece of paper? A bit, at least. Okay, go to your next page, please. And you will notice that it's a big blank sheet. Angles in the real world. That font is called Thunderstrike, in case anyone cares. I got a thing for fonts. I'm a bit of a geek, as you may or may not have noticed from the Star Wars, Star Trek discussion earlier. Angles in the real world. Look around you. We can look in 3 dimensions, yes? Up, down, left, right, and everywhere in between. Cool? Okay. So in the real world, we have to make a differentiation for where we are looking. All right? Don't write down what I'm about to write down. That's just a triangle, yeah? It's got 3 angles in it. If I want to put that triangle into the real world, and I tell you that you are right here, there's you. How do you know where to move your eyes to make that angle? Do you know? No, you don't. Because that's an angle on a piece of paper. It's not real life, okay? So, in the real world, we have a couple of ways of discussing and describing where we put our eyes. What is one of the things we can do to tell someone where to look? Pardon? Point. And when we point, we're going to point what? Forward, backward, left, right. We have all these words to describe it, don't we? What are some other words we have to describe directions? Key word there was directions. North, east, south, west, right? That's the other thing we do. If I tell you to walk 30 degrees north, well, okay, well, if north is that way, I must walk 30 degrees, so I'm going 30 over there. Everybody cool? Okay. Now, is there another way we can do directions? We've covered north, east, south, and west, and left and right, so you can move me around on the ground. Is there another dimension? Up and down. Absolutely. So, in the real world, we have directions, which are north, east, south, and west. And that's how we always draw it, right? No matter where north is, we put north at the top of the piece of paper, right? And we also have height, because I can make my eyes look up or down too, can't I? Everybody with me? I don't know why it hasn't shown up yet. There it is. So here is an eye, and that eye can look up or that eye can look down. Is everybody with me? If the eye doesn't look neither up nor down, it must be looking straight ahead, yes? Everybody cool? Okay. If the eye looks up, that is called an angle of elevation, because my eye has to look up. Now, I'm going to do something that's going to make this person very uncomfortable, but I'm going to do it anyway because I think they can take it. Where is my eye right now? Looking straight at Brooklyn. Everybody agree? It's flat, yes? We are eye to eye right now. Brooklyn, stand up. What do I have to do with my eyes to keep eye to eye with Brooklyn? I have to lift my eyes, which makes what kind of angle? An angle of elevation, because my eyes went up. Everybody with me? Brooklyn, stand up. Brooklyn and I are almost the same height. We're close because I'm short. We're eye to eye, yes? Brooklyn, sit down. Where do my eyes have to go? Down, which makes an angle of what? Depression is one of the words for it. This is depression. And there's other words. There is inclination and declination. But please notice it's between where your eye starts and where your eye ends. Kids have a lot of problem with that. Okay? And here's what I mean. I'm not even going to worry about directions. There's a building, yeah? Here I am on top of the building. Here is Brooklyn on the ground. I'll give her some pigtails and curly hair, and she's smiling. Okay? If I look down to Brooklyn, draw the line from eye to eye. Everybody agree? Everyone agrees, right? Now, from my point of view, where did my eyes start? Straight out here, yes? Which means this is what kind of an angle? That is depression. And it's just sad because I got to look at Brooklyn. Just kidding, as a joke. Relax. Everybody cool? Okay, now, Brooklyn's eyes start in what direction? Straight out here. Now, Brooklyn says, hey, there's some dude up on the roof. What's he going to do? She looks up. What does that make? That's elevation. Please notice that they are in different spots. Okay? The biggest problem I have in the 20 years I've been teaching math is you guys think this is my angle of depression. It's not. It's between where my eyes start and where my eyes end. Everybody cool? Now here's what's weird. What do you know about those two angles? They're the same. Her angle of elevation is the same as my angle of depression. Everybody cool? So I can draw two different triangles here, can't I? I could draw the red triangle and do trig from Brooklyn to Myers. Or I could draw the blue triangle. Nice triangle. It's fat like my belly. I can do the blue triangle from Myers to Brooklyn, and that would be depression. Is everybody cool? Okay, I'm not even going to worry about directions yet. We'll do them a little later on. Everybody good? Okay. Break time is in 5 minutes. So that's perfect because I'm about to give you an assignment. You are going to work on page 57 when you get back. Now you will notice page 57 has a title of page 76. That's so you can work with your outline on page 47 so you can keep going, know what we're doing. Everybody with me? All right. So you are going to work on that when you get back. Please notice I have supplied you with the answers. Okay? You can work right on your book or you can get a separate sheet of paper. I don't care. All right? Everybody good? And I'm going to give you some time to work on that when you get back from your break, maybe 15 minutes. Okay? Now, since you already have the answers, then how I like to work this bit of work is I say, okay, after 15 minutes, everybody okay? Well, I couldn't get the answer to number 20. So I go over just number 20. Everybody with me? Okay, so you got 5 minutes now. I'm going to give you 15, 20 minutes when you get back. Then we're going to go over it. Cool? Okay, go.